Welcome back, grade 9s. The last couple days we've dealt with what exponents are and adding and subtracting them, order of operations. And then most recently we dealt with the multiplication and division of powers. But what happens if we move even a little further up and we start talking about a power of a power? Well, it turns out we've got some pretty handy rules and tricks that can help us with those too, so we don't have to deal with really big numbers. So if we looked at a power of a power, it would be 3 to the power of 2, and then that to the power of 4. So if we wanted to write this as, sort of about the long way, this would be 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2. Because remember, we have to do it 4 times. Everything inside the brackets 4 times. 1, 2, 3, 4. Now, we take the easy step from here, because if these are all multiplied together, we know from 2.4 that we can just add all of those. So it would really be 3 to the power of 2 plus 2 plus 2 plus 2. Which is 3 to the power of 2, 4, 6, 8. All right? So let's look at the exponents that we have. 2, okay? And then we've got to go plus 2 plus 2 plus 2. 2 plus 2 plus 2 plus 2 is really just 2 times 4. There's 4 of them equals 8. So we can use that property to easily find out powers of powers. This time, instead of adding the exponents, we're going to multiply them. 2 times 4 equals 8. So this one, to raise a power to a power, multiply the exponents. Let's just look at that same example we've always had. A equals 2, m equals 3, and n equals 5. So what this would mean would be 2 to the power of m to the power of 5 equals 2 to the power of 3 times 5 equals 2 to the power of 15. So that's just an example of what that law is saying. Instead of adding the exponents like we would have if we were multiplying things, if we're doing a power of a power, we multiply the exponents. And again, this only works if a is not 0, and that m and n have to be full numbers. Okay? So let's look at the power of a product. Well, I hate that, so I'm just going to do that. 3 times 4 to the power of 5. Well, the bracket, the power is touching the bracket, which means we have to change this. Okay, we have to change this to 12, because that's 3 times 4 to the power of 5. So we're just going to kind of remind ourselves of that. Okay. Now what this really means is down here, okay, if I took this a different way, the power applies to everything inside the brackets. Now we can actually write this number in a different way, and sometimes this different way is easier. So we did 12 to the power of 5, which we know we can do from order of operations inside the brackets first. But when it's multiplication inside the brackets, another thing you can do is use the law that we're going to kind of introduce down here. But what you can do is you can apply the 5 as a power to both of these. So what you can do is you can go 3 to the power of 5, okay, times 4 to the power of 5. So the power, when things are multiplied inside the brackets, you can apply the power to each number. Okay? So if you look at the answer for this, when I plug it into my calculator, the answer for this one is 248,832. If I do the exact same thing over here, okay, if I do the exact same thing over here, remember, I cannot add the exponents because the base is different. I've got a 3 here and a 4 here. So I can't just go, it's 3 to the power of 10. That doesn't work because you've got different bases. But if I evaluate 3 to the power of 5, I get 243. I'll just kind of separate these out. I get 243, okay, times 4 to the power of 5, okay, is 1024. And then when you multiply the two together, you get the exact same number. So it's just two different ways of looking at the same thing. 832. You get the exact same number as you did before. So it's two different ways of looking at the same thing. So when we write our law, the exponent law for a power of a product, we've got A times B, because they're touching, to the m really equals A to the m, B to the m. So let's use our numbers here. We had A equals 2. Okay, we've got a new variable now, B, so I'm going to have to create a B. I'm just going to say B equals to 6. I haven't used 6 yet. And then m, okay, m was going to traditionally equal 3, I think, from our previous example. Yep. So what that means is if we've got, in brackets, just to keep it clear, if we've got 2 times 6 to the power of m, which is 3, that's the same thing as writing 2 to the power of 3 times 6 to the power of 3. Right? So that's a to the power of m and b to the power of m. A, m, b, m. Multiplication. So that is an exponent law when we're dealing with a power that applies to multiplication. Okay? So power of a quotient, okay? Power of a quotient is almost the exact same thing, but using division instead of multiplication. So if we look at 5 over 6 to the power of 3, well, if I try to divide 5 by 6, I'm going to get some sort of decimal, right? So it's going to be a really frustrating number to deal with. So let's just use basically the opposite, the inverse of what we used before. Instead of trying to figure out what this fraction is as a decimal, which is going to get really nasty, let's just go 5 to the power of 3 over 6 to the power of 3. So that power applies both there and there. So it's important to remember that the power is applied to both the numerator and the denominator. Now, we can't use the subtraction method because the base isn't the same. We've got a 5 here and a 6 here, so I can't subtract the powers. At this point, you actually have to figure it out. 5 to the power of 3 is 125. 6 to the power of 3 I've forgotten, so I'll just punch it in my calculator. It's 216. So as you know, that's going to be a decimal anyway. Now, most of the time, I think in this unit, we'll leave it as the fraction. But if we were to crunch that out, 125 divided by 216, we would get 0.579. Okay, now just as a thought experiment, okay, I'm going to go 5 divided by 6, just like on our original question, and then I'm going to apply the answer to the power of 3, and I should get the same thing, 0.579. So if I had gone the other way, and I don't want to confuse the issue, but if I had just done 5 divided by 6 at the beginning, and then had that decimal to the power of 3, I get the exact same answer. So it's just kind of a different way of writing it. But it's a lot neater because we've got nicer numbers here and here. So this is the exponent law for power of a quotient. So we know that quotient is division. Let's go with our same numbers for our example. A equals 2. I think B equaled 6. And M equaled 3. So what that meant was, if we have in brackets A to the power, A over B. Okay. Why am I writing out as A's and B's? I should be writing it out as numbers. Yoink. There we go. That's what the example is for in the first place. So we had A over B, and I probably should simplify that. Okay, to the power of M, which was 3, I believe. What that really means is, okay, it's 2 to the power of 3 over 6 to the power of 3. All right? So just a simpler way of writing the question. And it's very important to keep these straight from the straight division where we had the same base. If we don't have the same base, in this case we've got a 2 here and a 6 there, we can't do that subtraction. So it's important to keep that straight. So that's why the practice for this unit is very important. Because you see questions that look similar, but actually mean quite a different thing. Okay, let's look at this one. We've got -7 in brackets to the power of 3, and then all that raised to the power of 2. Well, we know we can use multiplication on this. So this one's really -7 to the power of, should probably write a 7 in there, to the power of 3, but because it's a power to a power, we can multiply. So this is -7. Gee, I need another coffee this morning. This is -7 7, not negative 4. Okay, so, oh, I erased something here. This should be 7, and then 3 times 2. So our final answer, because we want to write it as a power, is negative 7. 3 times 2 is 6. Look at the next one. Okay, negative sign outside the bracket. That's important. This 5 is touching this bracket. This 4 is touching this 2. So you just kind of work from the inside out. The negative sign has to stay out front because it's not inside any of the brackets. Okay, so it's going to be 2, okay, keep that negative outside the bracket, to the power of 4. And then because it's a power of a power, multiply the 4 times the 5. And what we get is negative bracket 2, 4 times 5 is 20. And the last one, same thing, very similar. There's no negative signs. The 2 is touching the 6, so the power of 2 is touching the 6. The power of 7 is touching the bracket. Okay, so this one is just equal to 6 to the power of 2 times the power of 7. Okay, 6 to the power of 2 times 7 is 14. Okay, so there's not a whole lot of math in these. You know, it's just multiplication as long as you can recognize how to work with the base. Okay, these ones are a little different. This is sort of the second example there, where we had products to a power. Okay, so let's apply the product to each power. So let's just apply that product to each power. Sometimes I do this just so I don't forget. So what this number really equals is negative 7 to the 2, because it's squared, times 5 to the power of 2. So the power of 2 applied to both of the products, or both of the factors, sorry, in here. Okay, negative 7 squared, okay, it's going to be positive, so it's 49, times 5 squared, we know is 25, and just pound that into my calculator. 49 times 25 equals 1,225. Okay, next one. Okay, this time it's division, not multiplication. Just put the dot there so I don't forget. Division, not multiplication. Okay, so, but the same thing applies. Always rewrite multiplication statements at this grade and above. Write them as fractions. It makes it so much easier. So what this really is 24 on the numerator, divide by negative 6 in brackets, okay, and that whole thing is to the power of 4. So we can rewrite this as, remember, just the 4 is going to apply to both of them. Okay, so it's going to be 24 to the power of 4 over, okay, negative 6 to the power of 4. So if I look at my calculator, 24 to the power of 4 is going to be a big number. Okay, it's going to be 331,776. 331,776. Big number. 776. Over negative 6 to the power of 4. Well, okay, it's an even number of negative sign, so the answer is going to be positive. Okay, so 6 to the power of 4 is 1,296. 1,296. All right, let's divide those two numbers to get our final answer. 331,776 divide by 1,296, and our answer is 256. Okay. Now, I just want to try something here. What happens if we were to simplify, okay, before we applied the power? Thought experiment, because some people are going to try to do that. Well, what's 24? Let's not apply the exponents yet. Let's try and simplify this. What's 24 divided by negative 6? Okay, well, that's going to be negative 4. And then we still got to keep the exponent. Negative 4 to the power of 4, okay, negative 4 to the power of 4 is, lo and behold, 256. Okay, so in short, if you're the kind of person who likes to simplify those, okay, before you do the math, you can do that. Just don't forget, you can't subtract, because these are different bases. You can't subtract these exponents. You still have to apply the 4. Or you can just do it sort of the longer way, where you take 24 to the 4 and then divide it by negative 6 to the power of 4. You get the exact same answer. So for those of you who kind of like to simplify things a little bit in that manner, you can do that as well. All right, number 10, a few more here. All right, negative sign outside the brackets, that's important. Multiplication inside the brackets, also important. So let's keep that outside the brackets. The 2 applies to both. Okay, so it's 3 to the power of 2. Remember, it's not 3 times 2, it's 3 to the power of 2. So this is really 3 to the power of 2 times 2 to the power of 2. So we've still got the negative on the outside, okay? And then 3 to the power of 2 is 9, and 2 to the power of 2 is 4. So our final answer is going to be, well, that's 36, so negative 36. Okay, it's order of operations. You got to be really careful with the negative, minus signs, negative signs. 78 to the power of 13. First, I'm going to check. Does 78 divide 13 nicely? Oh, it does. Oh, okay. So this one I'll do 2 ways. Okay, I'll do it. What I consider the easy way and the hard way. This is the harder way, but the way that if you follow all the steps that we've been doing so far, this is what you would come up with: 13 to the power of 3. Okay, so 78 to the power of 3, huge number. This is why I recommend doing it the easy way. That is 474,552. So this would be 474,552 divided by 13 to the power of 3. 13 to the power of 3 is 2,197. Okay, so let's divide those two numbers. All right, so 474,552 divided by 2,197 equals 216. Okay, now that's what I would consider the hard way. Okay? Okay, so let's call it the hard way. Okay, this is what I would consider the easy way. You just got to be careful for one thing. Okay, 78 over 13 equals, to the power of 3. If I do the simplification in the brackets here, okay, 78 divided by 13 is 6. So this actually isn't a decimal in here. It's really just 6. And then you got to keep the 3. So what's 6 to the power of 3? 6 to the power of 3 is 216. Now that I consider was a lot easier, right, than all these big numbers. You're going to make mistakes with these big numbers. So if you get a fraction or a division statement like that, you might want to check, does it divide out evenly? If it divides out evenly, it's probably a lot easier. Well, it's probably a lot easier in any case to do this method. So I would, keep that in mind. I would do it that way. If you just like going step by step and kind of powering through it, you're fine to do that. Okay, simplify, then evaluate each expression. Okay, so basically we're trying to find the answer. That's the evaluate part, but it'll help us if we simplify things first. We have the same base here. We've got a 3 and a 3, which means if we're doing multiplication, we can add those exponents. So let's just rewrite this as 3 to the power of 2 plus 3 is 5. And then that is all still to the power of 3. Okay, minus, we've got 4s, so that's the same base, and we've got multiplication again, so let's just write this as 4 to the 3 plus 2 is 5. And that's all to the power of 2. So we save ourselves a lot of trouble by rewriting it this way. 3 to the power of 5 to the power of 3. Now it's to the power of a power, so that means we have to multiply these two. So that's 15. Okay? Minus, now keep in mind the negative sign is outside the brackets, so this squared, or 2, only applies to everything inside the brackets, which is the 4 over 5. So this is minus 4. 5 times 2 is 10. Okay? So now we've got 3 to the power of 15 minus 4 to the power of 10. We no longer have nice equal bases, which means, unfortunately, we're stuck with the long mathematics. Boy, they gave us some big numbers for this, didn't they? 3 to the power of 15 is 14, 3, 4, 8, 907, minus 4 to the power of 10. 4 to the power of 10, that's a big number. Minus 1,048,5,076. Big numbers. 14,348,907. Subtract 1,048,576 equals 13,300,331. Not pretty. Not pretty. Is there an easier way that we could have done that question? Let me think about it. you know what? Not really. We could have done it slightly different by applying the 3 to each of those numbers and the 2 to both of those numbers. But at the end of the day, we're still going to come up with something like this, which means we just have to plug it into our calculator. Probably not the greatest example in the world. I don't like working with huge numbers like that in Math 9. It just leads to mistakes. Maybe that was the point, just to, to check on ourselves. Okay, let's go to this one. Now we've got a 6 times a 7 in brackets squared. Well, that's nice and easy because we always do what's in the brackets first, right? Bedmass. So really this is just 42 to the power of 2. Okay, we didn't really change anything there. Okay, now this one is, okay, so we've got 3 to the 8 divided by 3 to the power of 6. So let's do a little quick math here, but while we're simplifying. So it's 3 to the power of 8 over 3 to the power of 6. Okay, and we can't forget we've got this 3 on the outside. All right. Now there's a couple things we could do here, but why don't I just work with this for a second? Okay, let's work with this for a second and see how we can maybe change things. So we've got 42 squared on this side still. If we're simplifying this is division, and we've got the same base. We've got 3 here and 3 here. So we know we can subtract those. So let's just make this a little easier, and let's make this 3, okay, to the power of 2, 8 minus 6. And then we got to keep that 3 on the outside because we haven't dealt with it yet. Okay, just going to get rid of a couple of these little artifacts my hand caused. Okay, now we've got a simpler question, right? We've got 42 squared over here plus 3 to the power of 2 to the power of 3. Well, we know that we multiply these when it's a power of a power, so it's 3 to the power of 6, 2 times 3. Okay, now, there isn't a whole lot we can do with this. We got a 42 base, we got a 3 base. We basically just have to crunch it out in our calculator now. So 42 to the power of 2, 42 to the power of 2 is 1,764, and 3 to the power of 6 is 729. Okay, so we just got to add those up. Okay, 1764. And our final answer is 2,493. And sooner or later, you just get down to a point like this where you have different bases, and there really isn't anything you can do except do this one, add them together, or subtract them on this one over here. Okay, let's try and make this as simple on us as possible. Holy cow! We got a gift. Keep your eyes out for stuff like this. There's a whole bunch of math in here. But what's important is we've got brackets here and a 0 here. Anything to the power of 0 is 1. So the 0 is touching the bracket, which means anything in this bracket to the power of 0 is going to be 1. Keep your eyes out for those, because those are gifts, right? And that's why it's important to know your 0th power. Okay, so that is the end of 2.5, I believe. I'll post the notes. I'll post the video. The textbook questions will be there. Don't forget the answers to the questions are posted as well. And if you have any struggle with anything or you need a little extra explanation on concept, make sure you email us. Have a nice day.